Assalamu alaikum. My name is Hamza Masood and my registration number is 16T49. I am a student of UT Texla Telecom Department. Let's start our lecture. In our sixth lecture, we will study about the transformation of signal. So we have seen this diagram a lot of time. We have x of n and the system, and this system transforms this signal, input signal, into a output signal y of n. So what this system is doing is transforming input signal into an output signal, that is our desired signal. So we're gonna see what is happening inside this system, this box. So to convert this input into output, we have a lot of method. The first one is direct method. We will see how we can transform input signal to output signal using direct method. I have written an example. Y of n is equal to x of n minus 2x of n minus 1 plus 3x into n minus 2, where x of n is given. So what we will do to obtain output, we will put value from the value of n from minus infinity to infinity to get the output, our required output. So first I will find y of 0. Why I am finding y of 0, why not minus 1, minus 2? Because we see that x of n is 0 at minus 1, minus 2. So we get y of n also 0 when n is less than 0. So that's why I am finding the first value at y where n is equal to 0, y of 0. So by putting y of 0 in this equation, we get x of 0 minus 2 into x of n is 0, so we get minus 1, 0 minus 1, plus 3 into x, n is 0, so it becomes minus 2. So by putting the value, we see that at x is equal to 0, we have 1. So we write it 1 minus at x index minus 1, we have here 0. So 0 plus at minus 2, it is also 0. So we get y of 0 is equal to 1. Again we will find y of 1, which is equal to y of 1 minus 2 into x of 0 plus 3 into x of 0 minus 1. So x of 1 is 1, 2 into x of 0 is 1, plus this is 0, and we again get value 1 minus 2 minus 1. Now we'll find y of 2, which is equal to x of 2 minus 2 into x of 1 plus 3 into x of 0. Here it is 1 minus 2 plus 3, because at all these values we have 1, 1, 1. So we get 3 minus 2 plus 1 plus 1 plus 2. We get 2. Now y of 3 is equal to x of 3 minus 2 into x of 2 plus 3 into x of 1. At x of 3, here we have 0, 0 minus 2 plus 3, because at index 2 and 1 we have 1, 1. So we get 1. At y of 4 is equal to x of 4 minus 2 into x of 3 plus 3 into x of 2. Here we have 0, 0, and at index 2 we have 1, so 1 into 3, 3. We have 3 here, and all other values are 0 up to infinity. So we can write it as output y of n is equal to 1. This is first our index value because there is y of 0, have -1, and we have 2, and we have 1 and 3, and all other values are 0 on the right side and also on the left side. The second method is impulse decomposition. We have already studied what is impulse decomposition. We have input signal 1, 1 and 1. Now we will decompose this input signal and pass through a system. Decompose the signal into simple impulse signals and pass through the system. For this purpose, we first calculate the impulse response of a system. The shortcut method of calculating the impulse response, we have said that we can write h of n is equal to, we write all the coefficient of this equation. So what we will do, this is at 0 position, so we have here coefficient 1, and this is our 0 index value because there is no shift in this n, and the second value is -2, and the third value is 3. So this is our impulse response for this system. So we will convert this signal into a impulse signal, shifted impulse signal. So the first we'll get at 0, we'll get 1, and second we'll get here 0, here 1, and third one is we have at 2. This is delta of n, this is delta of n minus 1, and this is delta of n minus 2, and this is also the coefficient x of 2, this is x of 1, and this is x of 0. Here we have value 1 because all the values are 1. So what happened when we pass this through a system, the signal when passed through a system, what we'll get, we have impulse response y of n. So this is impulse, we get impulse response h of n, because this is nothing but an impulse, unit impulse, so we get impulse response. When we pass through this shifted impulse, unit impulse, what we get the impulse response, but it is shifted to the right, h of n minus 1. This will happen same for this impulse, we'll get h of n minus 2. So what is happening in this, if we generalize this, what we are performing, we can say that y of n is equal to summation k is equal to minus infinity to infinity. We are getting x of k multiplied with h of n minus k. This is we are getting in these equation. We are getting the shifted impulse response, and the coefficient is 1 because we have the signal 1 1 1. So this is we are getting. So this is the concept of impulse decomposition. Now we solve this concept with the help of this system. We will draw these impulse response and sum all these signal. This is, let's suppose, h of n. What we have at 0, it is 1, at 1 it is minus 2, and at 2 it is 3. This is h of n. Now we will draw the shifted version of impulse signal. Here we have 1, here 0, and at 2 it is -2, and at 3 it is again 3. This is h of n minus 1. Now the third version is starting at n is equal to 2, which is 1, and at 3 it is -2, and at 4 it is 3. Now by summing all this signal we get at 0 index we have 1 plus 0 plus 0. At 0 we have 1, and at index 1 we have -2 plus 1. -2 plus 1 means -1. At 1 we have -1. And index 2 we have 3 minus 2. 1 and 1, 2. 2 we have, at 2 we have 2. And at 3 we have 3 minus 2, 1. And at index 4 we have 3 plus 0 plus 0. So all other values are 0. Here we have -1, which is 0. So if we write the output, we get y of n is equal to 1, which is our index value, -1, 2, 1, 3, and 0. So this value is same as we have previously solved this system using direct method. Now the third method is most important method, that is convolution. What is convolution? It is the operation performed on two signals and give us output signal. The operation, it is like operation of addition or multiplication of subtraction, which take two numbers and give us a third number, but the convolution take two signals and give us the third signal. So we will take the same example. Y of n is equal to x of n minus 2 into x of n minus 1 plus 3 into x of n minus 2, where x of n is equal to 1, 1 and 1. And we have impulse response h of n is equal to 1, -2 and 3. In this convolution method, we first flip the impulse response. We will take h of minus n is equal to 3, -2 and 1. So we have flipped the impulse response, and convolution is nothing but flip and slide. We have flipped this signal, is this impulse response. Now we will multiply their index one by one and sum all the signal at the end. Let's look what happened. We have x of n is equal to 1, 1 and 1. This is my zero index value, and the flip impulse response we have here 1, -2 and 3. So we can multiply 1, 1. We are hearing right y of n is equal to our first value, index value is 1 because our index is matching here. This is 1, and the next value, if we have flipped first and now we will slide to the right, we'll get here -2, here 3, and here 1. So we get 1 into 1 1, and -2 into 1 -2, which is -1. So we'll get the second value -1. All other values here are 0. We already know that here we have 0. So if we again shift to the right, we get 3 -2 and 1. 3 -2 plus 1. We are multiplying and adding these terms, so we will get 3 -2 plus 1 2. So we here write it 2. Now again shift to the right, we'll get 3 -2 and 1. So by adding these values we get 3 -2, which is 1. Now again shift value, we have 3 -2 and 1. So we multiply this one by 3 and all other values are 0, so we get 3. We can write 3, and if we again shift further to the right, we get 0. So this is our output signal. And now if we see, this signal is same as we have solved the the same example by previous method, impulse decomposition. So the output is same. So we can use either of these methods for our convenience. The convolution is the most important and widely used. Now we have another example. We have system y of n is equal to x of n minus 2 into x of n minus 1 plus x of n minus 2, and we have signal x of n 0, 0 and 1. So we can solve this example with the help of convolution. So the impulse response of this system should be x of n 1, minus 2 and 1, where this is 0 index value. Now what we will do, we will flip this impulse response, which is 1, minus 2 and 1. Now we again flip and slide and solve this example. We have x of n is equal to 0, 0 and 1. And we write here 1, minus 2 and 1. Now we multiply, we get 1 into 0 and all other values are also 0. So we get y of n, the first value, that is 0 index value, is 0. Now if we again shift to the right, we get minus 2, 1 here and 1 here. So this is 0, this is 0 and this is also 0. The next value is also 0. Now we again flip, no, not flip but slide, 1, minus 2 and 1. This is 0, this is 0 and this is 1. So we get 1 here. Now again we slide 1, minus 2, 1, we'll get minus 2. Again we slide, we get 1, minus 2, 1. We'll get 1 into 1, 1. Now if we see this, we have solved this system and we have get the output. Now if we see this output is nothing but a shifted version of our impulse response. Why this is shifted? This is the property of convolution. When we convolve the signal, which is nothing but a shifted impulse, our signal or our impulse response is also shifted. That's why we have zero index value is at +2 where it is at 0. The system we have involved this example is not a ordinary system. If we write the system as y of n is equal to x of n minus, here it is x of n minus 1 into minus x of n minus 1 plus x of n minus 2, and now write in this form x of n minus x of n minus 1, and taking the minus common from here we get x of n minus 1 minus x of n minus 2. So what is happening, we are taking the difference between two consecutive values, and by taking the difference between two exactive values, again we are taking their difference. So this is nothing but a second difference system. Now we will see what is correlation. Correlation is somehow related to the convolution. In convolution, what we will do, we get two signals, x1 of n and x2 of n, and we in convolution we take the and flip one signal and we slide the signal and add the signal, and we get a third signal, x3 of n. This is what we do in convolution. In correlation, what we are doing, we are taking two signals, x of 1 of n and x2 of n, and we are not flipping any of the two signals, but we are sliding and adding the signal and obtain the third signal. This is useful when we are dealing with radar system. What we will see that the signal we are sending and the signal we are receiving, either the signal is same or not. In correlation we have two types, cross correlation and autocorrelation. Autocorrelation is used in radar system. Autocorrelation, I have already told you that in the radar system autocorrelation is a correlation of signal x1 of n with its shifted version x of n minus 2. If we correlate these two signals, we call this as a autocorrelation. And if we take the correlation between two different signals, x1 of n and the second x2 of n, or either n minus 2, it is the cross correlation. This is cross correlation, and this is auto correlation. So this is all for today lecture. अस्सलाम वालेकुम. आज का हमारा लेक्चर कंप्लीट हुआ. मिलते हैं नेक्स्ट टाइम. अस्सलाम वालेकुम.